So what is RStudio? I'm going to answer that now. So RStudio is an integrated development environment, otherwise called IDE, which sounds like a lot of jargon, and it kind of is. But basically, it's just a place for you to write code in R and also see the output. So to run the code, see the output, see plots in a nice single environment. And it really helps because it makes things a lot easier. You can basically press tab and it'll auto-populate lots of things. And so we'll go through some of that together. It's not as easy as some other tools that have drop-down menus like Stata, but there's some packages that can kind of help with that if you really want that. Although we'd recommend trying to use it in the way that we're going to describe in the class. So ways in which RStudio helps. First of all, it makes things easier by doing syntax highlighting, code completion, helps with indentation. It helps you see if you need another parentheses or another set of quotes. And it helps you to manage your files and directories, which is really great. It also gives you a sense of context. So it shows you this nice workspace and it allows you to view your data. It gives you plot history. You can look at your plots, which without the IDE is really tricky. You have to have another software program to show them. So that's one of the main reasons to use it. And you can find your files and export them and import, and also get really helpful information and tutorials about R. And we're going to show how to do a lot of these things. Okay, so for many of you, when you opened RStudio for the first time, it probably looked something like this. You had this big panel called console and then two smaller panels with more tabs on them. And indeed, to create a 4-panel looking RStudio, you need to first open a script or an R Markdown file. So you could press this little plus button on the left corner and then open something here to open a file. And that would open an editor on the top and the console on the bottom. So the editor is basically for writing static code. So it's where you would put your script, if you will, or code that you want to keep because you want to reuse it some other time. And the console is more for interactive testing, or using it as a calculator, for example. So the source editor is usually on the top by default and the console's on the bottom, but if you've moved things around, this can change. And there are ways to get it back to default if you'd like. And we'll talk about that in a second. So here on the top is the editor. Again, this is where the static code lives. This is where you can write code as well as comments. And you can press Command Enter, Control Enter to run single lines of code if you want to make it faster. And we'll also show you other ways in which you can run code as well. And importantly, it'll be saved on your disk if you press save. In the console, however, this does not get saved. You will have a history of the commands that you've run, and if you press the up arrow, you'll see what you last ran. But it's really just for testing things out. There's a ton of different things that you can do in RStudio, and it changes over time because they're always developing it to make it even better. So you can find this cheat sheet, but it's really complicated looking, so don't worry about it. This is more of after you get comfortable in the class using RStudio, you can find out about all sorts of nifty buttons that can help you work faster and more efficiently. Okay, so if you've opened a file, it'll look something like this with these 4 panels. But if it doesn't, you can go to Preferences and Pane Layout, and you can select what things go where. So let us know if you're struggling with that, and we can help you to pick the right preferences. And so at the top here, right, you'll have this section that has something that says environment, history, build, may or may not say Git, probably doesn't. That's for version control if you're interested in that later. But if you create any data, you're going to see that in the environment. And so this shows you what objects you have to work with in R. So what's loaded into memory, what data have you read in, what can you use? And your history shows your previous commands, which can be really helpful, but again, we would suggest that you not rely on it. And I said previously, you can use the up arrow to see what your past commands are, and that's super, super helpful. On the lower right panel, you'll see a file pane, a viewer, help, plots, and packages. So files just shows you the files in the directory that you're on, and you can move around on your computer and see other files, which is helpful for finding data. Viewer will show you data objects, and help shows you documentation. Plots will actually show you your actual plots, and the package pane is for showing you which packages you have loaded in memory. So I know that was a lot of information. This is the sort of thing that when you're immersed in it, it'll become a little more sensical. So we're gonna do just a very casual lab to start out with. And so we're just going to do 3 things, which is basically download this file at this link, which is also on the website under the lab for RStudio. Find that file on our computer and open it in RStudio. And again, here's the links if you're struggling to move files around on your computer. So we're going to pause for a moment and just basically do this lab, which is to get the file into RStudio and see if we can have 4 panels and have a similar view as to what I showed.
Do we want to break out for this or do it all together?
I think we could do it all together. What do you think, Ava?
I think so too.
Okay, so I'm going to walk through this to help. So I'm going to stop my share and share with my screen, my whole screen. Okay, can you see the whole screen now?
Yep.
Great. All right, so I'm going to click this link, and on my Mac, it's going to automatically show in the corner of my browser. And so if I click on this, because I already have RStudio open, it's going to open it in RStudio. So here I have RStudio Lab. I've had it many times, that's why it says 14. Yours probably won't. And now I have 4 panels. If this is not the way it showed up, you might need to go to your downloads, which I believe is what you would need to do for a PC as well, or a Windows machine. And so you would need to search first on your computer for your downloads and move your RStudio Lab into the directory that you plan on working. So maybe you're working on your desktop or your documents, then you would need to move that file and save it there.
So we got a good question about what happens to the file. And so some applications and programs, they will create what's effectively a copy of the file. R does not do that. You have to keep the original file. And so put that in whatever folder, an intro to R folder, put that wherever makes sense to see it later, because that's the source of ground truth. You do need to keep that file.
Yeah, it's a really good idea to just set up a directory somewhere, probably in your documents, where you want to do all the work for the class and just continually save the files in that directory. Okay. So again, don't worry if you're not quite to this point, we'll have plenty of time to go through it. But for those of us who are just going to be with us, until we get through all the material, then we'll move along. Actually, I don't want to talk about that because, yeah, so we're going to be using what's called R Markdown files, which have a .rmd, and they're helpful for generating reports. So that will have your code and the output of your code, which is really important. So that proves that your code actually probably works much more than a script. And so you can think of them as a fancier script because it has the code and the output. And you can also put lots of information about what the code is doing, which we highly recommend because it's hard for you to remember and for your other colleagues to understand what you did necessarily if you don't tell them. And it's also great because you can create many different types of files from it. So you can output a Word document report, a PDF, or an HTML. We recommend HTML because it has more interactivity. And so the way that you would do this is, we just had you open an R Markdown, but you can actually create one yourself. And you would go to File, New File, R Markdown, or you can press this little button here, which is like a white square with a plus button, and then you could press R Markdown. So I'll demonstrate that now. So here's the square button. So I can press this and I can press R Markdown. It'll pop up a new pop-up that says new R Markdown, and I'll title it untitled. and that's what it looks like. Otherwise, we could go to File, New File. Share my desktop for that. So File, New File, R Markdown. All right. And inside your R Markdown, you'll see what's called a chunk, a code chunk, which is basically just this gray area that has these special buttons. And that allows you to write code and run it. And so whenever you create an R Markdown file, it's automatically going to create an R chunk with some array cars in it. And you can press this green button to run the code chunk, and that will create the output of the code. You can add new code chunks by either copy pasting the existing R chunk that's already there, or you can press the insert chunk button, which is this green C plus button at the top, and you can select R. You can see though, you can also work with other languages within R, which is pretty cool. And there's a really nifty button that's extremely helpful that when I was teaching myself R, took a while to figure out. And it's this run all previous chunk button. And so if you press that button, it will run all the chunks before the chunk that you're working on. And so that's really good for troubleshooting. If for some reason your code isn't working the way that you expect, you need to figure out exactly where the spot is where things break down. And now RStudio, if you have the newest version, has this really awesome option where you can click this gear button, and then you can select how you want that chunk to show in the report. So if you only want the output to show, you would have the output as only show output. Or there are several other options, such as show the code and the output, or don't run any of it, show nothing, etc. And so sometimes you want code for yourself, but you don't want to necessarily show it to your collaborator because it was something that you were trying out and you want to save it, but you're not necessarily ready to share with your collaborator. You can share everything else, but not that piece if you show nothing and you don't run that code. It can also be helpful if you have really big code, like for example, when you're loading packages, it's going to have lots of messages and things like that. And so you might want to not show that, but you want to actually run the code. So if you show nothing, run code. This is all going to sound kind of crazy until you start working with them and seeing the reports. And so we're going to work on that a little bit today. So the actual report generation button is this knit button. It has like a little spool of yarn, and that will knit it to the type of file that you want to send your report in. So if you want to create an HTML, which is what we would recommend, you would click the knit button and then knit to HTML. If you're into shortcuts, there's lots of nifty shortcuts. So Control Enter will help you evaluate one line of code, which is basically the same as copy pasting your code into your console, which you can also do. And Control 1 will take you to the editor or script, which is the static area, and Control 2 will take you to the console or the testing area. And there's a link to more shortcuts if you're a big fan. So in summary, RStudio makes working with R much easier. We highly recommend using it. The editor is where you have your static code, which is where your R Markdown files might live, and you'll write down, your code and also see the output of your code as well as information about what your code is doing. The consoles for testing your code. Our Markdown documents are super helpful for seeing what your code's actually doing and showing it to other people. And we'll talk a lot more about that in a second. So R goes in what's called a chunk, and it's the gray area with buttons, green buttons, and code chunks can be modified so that they show in different ways in reports. Okay, so we had some struggles with R versions and therefore compatibility with packages. So I'm going to go over the lab exercises now with everybody.
Were those issues with the remote package downloading?
Some of it, yes. Some of it was the JHUR. It was kind of everything.
Okay.
Yeah, versions matter a lot in R, unfortunately. That's what I was talking about with the trickiness at the beginning. But
yeah, I had someone come to me who had issues with the remote. I was going to post the thing on R help. Should I hold off on that since there were issues all around?
No, I think that would be great because I think there are different issues. So that would be helpful.
I'll do that.
Thank you. All right. So again, no worries if you're having trouble. We'll get you set up and running eventually. So here we have our lab, and so what we wanted you to do is try pressing the Run Current Chunk button. And if it works well, you'll see a nice green column go across. Sometimes this will show a little clock, which means that things have timed out and then things are not working very well. And then you might want to copy paste individual lines to see, because something's going really slowly is what's happening there. But for me, it worked well. And then here's our next code chunk, and I can do the same thing. If I wanted to run all the previous chunks, because this is our second chunk, I could press this button. So here I'm going to run it, just this chunk. And I see that I actually have made a plot here, which is pretty exciting. And then when I read through my exercise, it says that I can change the colors and I could change the days. So first I'm going to change this one to be yellow. And now I see that this has become yellow. Probably wouldn't want my purple route to be yellow, but this is just to show. And here I could say it's already Sunday, but I could do Saturday. And this is printing only Friday, Monday, Tuesday, so we don't have that data. But you know, I can play around with the weeks and see what happens to the code. And I'm going to try knitting this with the knit button. I'm going to change my share to my desktop. Okay, and so this is what I get from it. And here we can see our Saturday because the output's a little bigger. And we can see our yellow. So if I change this again and knit it again back to purple, it would show as purple. Now it's purple. And then we were also supposed to make a new chunk. So on here, I'll press the insert new code chunk button. And I'll select R. Now I have a new chunk. And I'm going to put this code. I can't put the backticks in. That's just to show that I'm using code. And I want to change this so that the settings are show output only. So I press this and I select show output only and I apply. And I press knit. Okay, so in this code chunk, we see the code and we see the output, which is the plot. And with other settings, with this last one, we did echo false, so we don't actually see the code. It doesn't show up. And so I can play around with that and try different settings and see what happens in terms of printing this other code chunk. So instead I could do show code and output. And now I see it here. There's no output for this code because we're not printing the X. So when we just do output, we don't actually see anything. A little tricky. All right. I think we have some questions. So when you knit, it does automatically save. If you do not knit, it does not automatically save. So you need to consciously save. And yes, we knit so that we can create this HTML or Word or PDF report, and it shows the output of our code and also what our code is doing, and it shows it for the whole document. So if there's a problem earlier in the document, we'll discover that because it won't knit. So I'm back on our website and I'll show where I am again. I went to reproducibility. We're still in day one. This is the last thing. All right. Everyone can see it. All right. So what is reproducibility? Why does it matter? Reproducibility is super important. The concept is basically if a different person takes your code and takes your data, do they get the same result? Or even yourself, but at another point in time. And this material is from Candace, who's written a really nice series of courses about reproducibility. So say you have this really great finding, you have this awesome result from some research that you did, and you first want to celebrate, but then you have to make sure that this is real and reproducible and repeatable. So we'll talk about the difference between those. Let's see that there's. Okay, so there was a chat about someone finding the wrong lab. So it'll be the lab for the day that we're on. And we'll, again, try to further point that out next time, but from the website. Okay, so repeatable. The idea of repeating something is, can you yourself get the same result twice? So first you just want to try to get the result, and then can you get it twice? And the next step is having someone else or you in the future. So reproducible means that you can do the same analysis, but in the hands of another person and get the same results. So previously we were just Ruby, and now we have also Avi getting the code and the data. And do they get the same result? And replication is when we have someone using different data, but trying a similar analysis and showing a similar finding. And so when we think of all of these together, repeatability is the easiest to obtain. So same researcher, same data, and that's the first step that you need to do. Reproducibility is a new researcher and the same data. And then replicability is when you have new researcher and new data. And ultimately for science and public health, we want our results to be replicable. So it starts with repeatability. Sorry, something happened there. So this is really important, as we know, because having replicable findings in science is how we know that we're reaching some sense of truth, which is what we're searching for. And so if we may have this situation, this happens quite often, especially with R, where Ruby does this analysis and she gets a correlation of 0.893, and then she gives her code and data to Avi, and he gets 0.891, which is pretty similar, but is that a problem? And sometimes it is, because sometimes it's the difference between significance and non-significance. In this case, this is a very strong correlation, and it may be because they're using different versions of R or something like that, which we'll talk about. But really, we want to get to the heart of it and figure out why we're getting a different result. It's important for us to figure that out. And so this is kind of a slower process in doing your analysis, but it's definitely worth it because the payoffs are very high. So like I said, this can be for your future self. So this is one of the major payoffs. If you do your analysis and then 3 weeks from now, after you've submitted a paper, a reviewer wants you to do some other analysis, and then, oh my gosh, my result's gone, what's going on? That is a horrible situation, and we want you to avoid having that. So that's why reproducibility is helpful. I think, yeah, sorry, I keep clicking a different button. So the process is to get your code to work once, get your code to work reliably for you, that you can repeat it, and then try to have a lab mate or a friend or colleague try your code as well. And so our Markdown is a really great way to help you do this, and which is why we're having you work in our Markdown now. So we could have you start in scripts, but you can't run your code and see what's happening very easily in the way that you can in our Markdown. And also it allows you to take notes, which is really helpful as you're learning to describe what you're doing. And it just gets you in the practice of working in R in a way that's reproducible. And so why is R Markdown especially great? It's because it's really conducive for what we're calling interactive development. So within her own, the same document, we can write the code and see the output directly. And so because we have the output of the code, the comments about the code, descriptions of what's happening, it makes it really clear what's going on. And so when you send it to someone else or you come back to it, it's much easier to follow what's happening. And if, for example, you want to make a simple update, like you want to change a parameter or you want to add more samples, it's much easier to do that. So here, Ruby's added 5 more samples. It was really easy for her to just update one part of her our Markdown file, run the whole file by pressing knit, and she gets the new result and a new report. So there's some other practices besides just using R Markdown that are really helpful to do. So one is to clean your environment. So there's this cute little broom icon. And when you hover over it, it'll say clear objects from the workspace. And it's a good idea to remove everything from your environment fairly regularly. Now, that being said, once you remove it, it's not there, so you'll have to rebuild everything. But it's a good idea to do this because it's possible that you did some command in your console or something that you forgot to put into your script. And then when you try to run the R Markdown file, it may not knit, or it may not have the results that you expect. And so this is a good way to make sure that our code is running as expected. And then as we know, the knit button is how we create this report. And if it doesn't knit, this is how we can figure out that there's a problem with our code. This is much harder to figure out from scripts, because here we can have individual chunks that we can run and figure out where the problem is. Again, R Markdown is great because it gives you an opportunity to tell others what you did. You have more of a way to format besides a script, which would just have comments with a hashtag and the code. Whereas in R Markdown, we can have all sorts of fancy formatting to make a really beautiful report that's clear. And so there's a lot of different R Markdown syntax, and you don't really need to know about this now, but if it's something that interests you, I suggest you check it out. And so basically you can create headers outside of an R chunk with the hashtag. Inside of a code chunk, it's going to create a comment. So that'll just be comments within your code that tell what your code's doing, but it's not going to actually create any sort of format change. But outside of a code chunk, it's going to make what's called a header. So here we see, because this has one hashtag, it's the largest. This has two, so it's a little bit smaller, so it's a subheader. And this is our regular text. We can make it bold with 2 stars, and we can make it italicized with 1 star. And the backticks is how we show code. And so that's why in the R Markdown file, when we had the X assignment to 1, 2, 3, and we had backticks around it to show that this was code. But when we're actually using it as code, we need to remove the backticks. If you want to learn more about R Markdown, you can go to help cheat sheets and R Markdown, or you can Google RStudio R Markdown cheat sheet, which is also linked on our website. Okay, another thing, we've started to see that versions matter because sometimes you can't even start the R Markdown, but also it can be something subtle like this, where we have a slightly different correlation value. And so making sure that we have the same starting R version and also package version. And so there's a function called session info that you can use to print out what which versions of R and which versions of packages were used. And there will be instructions in the final project for how to do this. But it's very simple. It's just including this in your R Markdown, and then it will print everything. So there are lots of additional R Markdown files, reproducibility resources. So there's this course that Candace wrote that's a beginner course, an introduction to reproducibility concepts, a more advanced course that gets into version control, and some additional resources as well, which are also on our website. So in summary, to make your work more reproducible, use R Markdown, clean your environment regularly with the little broom symbol on your environment, check the knit of your R Markdown regularly. So as you're writing a new chunk, press knit, see if it knits. Make a new chunk, press knit, because that'll show you where the problem lies instead of going back through many, many chunks. Make sure you write for your future self and for others exactly what you're doing, and print the session info.